Good morning. Good morning. How is everybody today? Thank you all for coming to the talk. My name is Russell Beatty. I am an HTML5 platform evangelist for Amazon. Today's talk is coding tips you should know before distributing your HTML5 web app on mobile devices. We are going to talk about a lot of stuff, a lot of slides, a lot of demos to go through. It's generally broken into these categories. I'm going to start, make sure everyone's kind of on the same page. We're going to go over some basics of HTML5 web apps. And then I want to run through the development cycle, actually like go through a little app from start to scratch and show you what that's like. And then I'm going to jump into some coding tips and best practices. So I've broken it down into kind of four main areas, the four main groupings of HTML5. But inside of these areas are two main themes I want to hit over and over again, which is control and performance. Control and performance. And so as we jump into each one of these, I'll probably call that out again. But just to kind of give you an idea of where we're going. So what do I mean when I talk about HTML5 mobile web apps? What I'm saying is I'm not talking about mobile websites, a blog that happens to be, you can look good on mobile. Or I'm not talking about responsive websites like, say, the New York Times or the Boston Globe, which looks great across multiple platforms. I'm talking about apps, mobile apps, that are made using HTML5 technologies like JavaScript, CSS, HTML, all the assets that go along with it. Real apps that look and feel just like regular native apps, but using the web technologies. So it's not about trying to figure out how to make this thing work and on random browsers. It's about targeting a device and saying we're going to make it look really good on that device, and going from there. Okay, so again, this is just to start from scratch. If you're familiar with web development, you're familiar with mobile web development. It's the same basic tools with just a few additions. You need your text editor, VI, Emacs, et cetera, et cetera. You need a modern desktop browser, one that has developer tools built in. Developer tools is the new view source. You need to have that in order to do web development, be able to go in and debug, see the JavaScript running, see what's happening to your page. You also need a modern mobile web browser or some sort of tester. Modern browsers, mobile browsers, whether it's Safari on iOS or Firefox mobile, Chrome mobile, Opera, all of them have dev tools built in as well. And so you need to be able to remote debug and connect to that device. And so you need a nice nice browser on the device to do it. Or you can use, I'm going to be using the Kindle Fire HDX, which has a web app tester, which is basically a Chromium full-page web engine. And so it has dev tools built in, so I can use that, and it makes it a little easier to test, but it's the same sort of thing. And if you're targeting devices that are Android devices, you'll need either the Android SDK for remote debugging. Chrome now has an extension you can download that will do this same sort of thing, but if you're targeting Firefox or on the Kindle devices, you'll need the Android SDK to do the connections you need. So I'm going to take a little bit of time on this one slide, and then after that, I'm going to start ripping through the slides. All of them are going to be available. The presentation will be available for download, and I encourage you to go see it afterwards. I'm going to try to talk about the slides and then give a demo, and so you may not have a lot of time on each slide. This slide, though, we're going to talk about. So this is a canonical single-page application that's meant specifically for mobile apps. And I'm going to go through each line, because they're all very important. The very top line, this is your declaration. It says, hey, I am now telling the browser, please use HTML5. And you might see variations of this, capitalizations and various things. This is what it looks like. Capital doc type, lowercase HTML. That's the sort of spec and the standard. The HTML can be in any case, because it doesn't look for it, but keep it in lower. So the doc type turns on the HTML5 goodness, and then the character set below, basically up until that point, the browser is parsing all of the markup as ASCII text. It's waiting to see, hey, what's the rest of the page? What am I using for a character set? So if you want to use a little like hearts or other characters in the rest of your page, you need to be able to tell the browser what you're using. This is where you do it. And again, there's lots of different ways of doing this. There's older ways that are like the HTTP equiv tags. This is, again, canonical for HTML5. So these 4 lines, you can copy and paste these. These are it. This is the way you should always do it from now on. You don't have to think about it anymore. I actually have been going back to my presentation and copying these every time I have to use it from now on. It's just a nice way to memorize it, to not think about it anymore. Right? All right, so we have a template title. And then this is probably one of the most important parts of a mobile web app. What this does is this is the viewport. It's been around since iPhone launched in 2007. And it's very, very important because it goes to one of our main themes, control. We want to know, as a developer, we want to have access to everything on the screen. We want to be able to know that the end user can't move things around if we don't want them to. We want to be able to know what the resolution of the screen is, and this is what controls it. I have some samples later. I'm going to go back on this, but this is probably the most important line there is. And if you take anything away from the presentation, make sure you know how to use the viewport because it's very important. Going down into our very small template here, you want to put some in-page style right up front before anything else. And this is because what you want to do is give the end user something to look at. Now, this could be a lot more complicated than this, but the point is that it doesn't have to go download the style from somewhere else. It's in the page. It's being parsed immediately as soon as the page is grabbed by the browser. And so now, in this one, I'm just saying, let's make the background black. Let's get rid of the margins so that the end user is just there waiting for something to come up. And if I have to go grab some bigger assets and download them, then it's not going to block. And this is where it's really important. If you put JavaScript above this, if you put CSS above this that you have to you download, for example, this next line, then it'll block until it gets everything down. Then it will start to render the page. You don't want that. So just put a little bit of snippet in there that says, hey, here's what the end user is going to see before the rest of the page comes up. Then your style. And then we'll end the head. Now, the head, in this instance, is very small. You're going to see very soon, I'm going to go over that it actually can get really big because this is where we tell the browser a lot about our application. And there's a lot of information we can put in there. So in many mobile web apps that I've seen, the head actually is larger than the body. The body is usually very small, just has a div or two in it to use as a anchor for JavaScript. And then the head has a bunch of information inside of it. So I'll go over that again in just a minute. And then we have our body. And then at the very bottom, we have our JavaScript. Now, if you've done web development, you know that there's various ways to get asynchronous downloads of your JavaScript. This is the most simple, the most basic way of just saying, hey, make sure the rest of the page is rendered before you go grab some JavaScript and bring it back to me. If you need to do more complex things, you'll need to use an asynchronous download manager, et cetera. But for many, many, many apps, this is the simplest way to just say, hey, make sure I have a page to render to, and then go grab the JavaScript and start rendering to it, and drawing to it. So this is our main page. I'm going to go back to this because I've used this on every single sample that you're going to see today. I've just used this as a main template and then expanded from there. So that gives you sort of a basic idea. This is our starting point. Now we're going to start to speed up and say, hey, let's take a look at ways we can do this. I'm going to go and I'm going to do a dev tools demo, which basically means that I'm just going to go through and show you what the whole life cycle of a small app is, a couple of them, and we can kind of get an idea of a sense of what the whole process is like. Okay. So again, any text editor will do. I'm using on my Mac, I have a Sublime edit, but VI, Emacs, etc. is good. So here's my template again. And what I'm going to do, the very first thing, is I have a basic app here. Has some very minimal CSS in it. And it just has maybe 30 lines of JavaScript. Line 11 basically says, let's use the geolocation API, get our current position. Once we have our current position, we're going to have a show position callback. So look a couple down, line 19. You can see that we have a very simple function that basically says, get an element from the page that just rendered. And I'm going to put the latitude and longitude into the page. And if there's an error, it'll show you an error at the bottom. It's a very simple demo. Now, I've connected over a USB cable to my Kindle Fire. And on my Kindle Fire, I have an app called the Amazon Web App Tester. It's a free download from the Amazon App Store. But again, it's a Chromium-based shell. And so I can basically, it helps me run my tests in a full screen environment. And so it's what I use as my tool to develop with. So here's our basic app. It's not very useful, but it's still a basic application. What we can do is we can just go into that same sort of code, and at the bottom in our show position method, we'll just do a call out to a Nokia API to get their maps application. And so it's the same sort of structure of an application, and now we have something that's a little more useful. Now here's a where am I application, and you could now package this up. This is, a very simple application, but it's something that would be easy to expand on with not a lot of effort, and you get an actual full screen web app that can go onto a phone and be somewhat useful. All right, so again, these aren't very complicated though. So let's move up a little bit, and we'll go to a more complex application. So here's an application I wrote in WebGL using 3.js library. And it's a basic 3D web runner. So I'm trying to collect the green squares and get rid of get away from the other ones. So we've got kind of a Tron effect going here. Now, it's not as performant as I would really like it to be. So I'm going to connect to it with the developer tools like I would normally do if I was going to view this on my desktop. So I'm doing desktop web development. I would pull up the page, do inspect element, or pull up the developer tools, and then start to look at the code. Let's do that here, but with our mobile tools. And I'm already lost. There we go. So I have the connection pulled over. I use this line here. It's a Android developer kit port redirect, and I'm going to connect to my game. And now we have the developer tools. Here, let me restart this. And I'm looking at the processes just like I would do on a normal application. So let's go into here and just go into, let's see, the animation. And we can just do a pause. And you're not seeing that beautifully because the screen's too big and too big. Let's see. OK. So you can see that I can actually step through the code just like I would normally do. I can also do, so I can control the browser. Basically, this whole developer tool instance is being served up from the device itself. So everything you're doing is actually being done on the device. So I can also go into things like, say I want to, that game over I think should probably be red, for example. So let's do inspect. This is on my desktop. And then I come over here and I click on the element. And now it's highlighted so I can see, oh, here, now I want to change that to another color. So let's just click on it and make it green. Did that work? Nope. Let's try that again. There we go. So you can see that there's bidirectional control. It's like I'm working on the device as if I was working on my regular web browser. So that's how the general development process works. But also you can do things like your profiling and your performance analysis. So we'll click on this again. We'll go to the timeline, hit the record. And now I can take a look and see how the performance of this application is going. And I can sort of move things around, check it out. All right, so this is basic developer tools. And if you've done web development, you've sort of seen this before. You can see at the very top there is a line. That line is, right now, says 30 frames per second. So you can see that we're getting not really a lot of frames per second. We're not getting as much as we want to. We can use developer tools go into each frame of the application as it's running. You can find the area where there might be some slowdown and say, oh, wait, why is this, here, let me expand this a little bit more. Why is this running so slow? So I've got another example of the demo, so we're going to take a look. And what I've done is gone into the code beforehand, and I fixed a few things. I've taken in account for the fact this is a 1920 by 1200 screen, which is the resolution of most laptops nowadays. Even the newer laptops have a nicer resolution, but still it's a very common resolution. But it's run by a mobile browser and a mobile CPU, mobile GPU. So it's a lot of stuff going on. So I'm going to reduce the number of polygons there, and I'm also going to use modern HTML5. Now the thing is, if you're targeting mobile devices, you're using the most up-to-date HTML5. There's no reason to use old tricks. If you're copying and pasting code from an article in 2005 or 2008 or 2009, you're using stuff that's really old. So there's a new function I'm going to cover briefly, request animation frame. It's a little nicer than the old timer because it's synced up with the redraw. And so the result of that is you get a much more performant application simply by doing two things, taking into account the fact that we have a mobile device and using the most up-to-date HTML5 methods, APIs, libraries. And we can go and confirm that, in fact, we've got a better performing app by going back into the DevTools, taking a look. And now that line is at 60 frames per second. We could definitely go back in, keep tweaking until we get below the 60 frames per second so that it's as fast as possible. So this is a general sort of this is how you go from basic app to a little better app to a full-on performant app, and then going in and making sure that it runs as performantly as possible. Okay. So now that we have we're all on the same page, we kind of seen the process, and we know what we're talking about. We've got control of our page and everything on it, and we can develop just very simply using JavaScript, your basic tools. I encourage you, by the way, not to go grab libraries first, jQuery and all that, but to use HTML5 and all the latest and greatest first before you go grab something else, like a library or something, to start working on, because there's a lot there. We're going to go through the 4 different areas, again, with the focus of control and performance. This first bit, the first few slides, are to just expand on what I was talking about before with the headers. There are a ton of headers for mobile devices. Apple came out with a bunch of them years ago, and some of these are a lot of them are for the icons that will come up if you save it to the home screen. Some are for whether you see a bar at the top. Some turn off some functionality. This is, again, I got like 45 slides. We're going to go through these quite a bit, but please go to the presentation afterwards. BlackBerry has its own. Google has their own. They've got a brand new functionality in Chrome, which allows you to save apps to the desktop. This is, again, like Apple had back in 2007. But they've obviously taken away the Apple prefix to it. And they've got some higher resolution icons, and this is how they get their icons. BlackBerry, this turns off the telephone. So if you have some text and you have a telephone number in there, you don't want it to auto-detect that telephone number. This is a header that you put in there to make sure that it's not there. Microsoft has a really great platform. The Windows Mobile 8 is very cool. It's got these great tiles. So if you save a page to your home page and you want that tile to have a different color and a nicer icon, and you want it to update automatically, this is a meta tag for that as well. So there's a lot of stuff in the meta tags. Firefox and W3C has theirs. There's even things like prefetching both the DNS and the actual page itself in the background. You can put those in the headers. So if you go to the Financial Times application, which has this great cross-platform app that's a mobile web app, if you take a look at their page, their header is huge and their body is just a few lines. It's almost reverse of what desktop apps have been like for a long time. There's a lot of HTML tags, and there's a lot of cool new stuff, but I'm just going to focus on a few of them that are interesting. These are all interesting, and then I find this to be very useful, and these are the input field types. These might make input fields on mobile devices actually more easier to use than on desktops. What is going to happen is, you've seen some of this already. If you put an email type onto a text input, it'll present you with the @ symbol and the .com and things like that. URLs, date times. Basically, and I'm going to show you a demo in just a second. The idea is that rather than having just a text and then having to write a bunch of JavaScript to kind of detect that text and kind of help the end user, a lot of the stuff is starting to get built into the browser itself. No reason to not take advantage of it. Same thing for the validation. You can put in a regular expression into the tag itself, and then now you can say, hey, I want this to be a URL, and it has to be formatted a correct way. And that's definitely not a great regex pattern, but that's an example. The idea is you can also do that, and then also it's linked up with CSS, so you can have custom CSS to kind of help the end user. So let's take a look at that. Just to take 2 seconds. Let's do, I think I can do full screen. There we go. All right, so the first one is a date, and I get a full date time input. Same thing there, but this one is set date and time, so there's variations here. Email, like I said, you've seen before, you have your @ symbol down here and your .com. Makes it a little easier. This one just gives us a month and a year. This one says, I just want a number. So that's good for various things. Here's the range. And again, I'm using this on Chromium. This is what this web app tester is based off of. But Firefox also has a lot of support for this. Safari is coming along as well. So it's 90% of the mobile web browsers out there, 90+% of smartphones are WebKit based. So a lot of the demos and code you're going to see is WebKit focused, and that's why. But you'll want to do prefixes for like mobile Microsoft devices and things like that as well. So here's a search one, and that's not working. OK, so let's see. Let's keep going. Telephone, and then down the very bottom, this is the validation. So it wants a website URL, and if I type in the pattern that was on the slide, then suddenly the red X mark changed to a green mark. And that could be anything you want to. It's just CSS. And that's very good. And there's no JavaScript there. So the browser's taking care of it. It's nicer. If you tried to submit that form, it would say, no, you can't do that because you haven't filled in the correct field. So this is just an example of using HTML5 because it's there. You might as well use it. And actually, it helps the user in a lot of ways. These date fields are great. Now I don't have to try to fight with the forms. And it makes it look a lot more native. And that's another good thing, too. So continuing. OK, so we're going to jump into CSS. First couple slides are about control. Again, it's something we want to make sure that the browser is meant to display documents and download it from the web and all that. We're kind of reusing it to make apps. So we want to make sure we restrict what we can do and what we can't do as much as possible. A lot of these WebKit, and there's various versions for other browsers as well. When I select, say I've got a bunch of text on the screen, I don't want to be able to highlight that by accident. So we want to get rid of that by the first line of the highlight color. There's also things like when you hold down and you can do copy paste on a text. We don't want that, right? So we can get rid of that by putting some CSS in there as well. We don't want people to be able to drag and drop items. We don't want them to. Oh, there's mine. There we go. Sorry, I'm trying to find what I can see. You want to make sure that there's. I'm trying to look at this slide here. That if you want to redo some of the even little things like the password, like dots, and you want to make those X's or squares or something, you can do that as well. So there's various ways. And again, this is just about controlling what the defaults are and kind of focusing on that. This is a slide about performance. And these are the 4 transforms you can do to do GPU acceleration. Now, I want to preface this by a little bit. I'll give a little bit of explanation. every time your browser renders a page, it goes into the renderer. The renderer takes a look at the DOM, looks at the hierarchy of text and images and everything you have in there, and says, OK, what do I do with this now? And it decides to divide things up into layers. And it's intelligent about it, very intelligent about it. It can say, oh, well, this is an image. I'm going to pass that right to the GPU. This is a bunch of text. I have to kind of keep track of that. So it'll do that itself. These things, if you do this in CSS, these transforms, translates, which means you can move it around, scale, make it bigger, rotate, and fade it in and out. These things can be passed right to the GPU, and the GPU will do the work. Now, the GPU loves stuff that's like on a matrix. It's like a flat. If you can put things into a mathematical matrix and then adjust those numbers, it can do that really quickly. So you have a grid or you have a cube. You pass that to the GPU, and it'll do all the math really quickly and then pass it back to the renderer to composite later. So if you do these 4 things, you can do animations with it. So the animations will then be passed to the GPU. They'll be really fast. Animations and transitions. They're essentially the same thing. Animations have a little bit of control in each point. Transitions are kind of like an automatic thing that you can say every time I change a CSS, a class or something, to do a certain animation. But both basically use the same sort of functionality in the sense that they say, OK, well, what do I want to do when I get there? Let me give you a demo that probably will explain it a little better. Oops. So the first thing I want to show is slideshow. Now, animations like this used to be done, like this, sorry. You can see as I let go of the picture, it slides over. Now, this used to be done a lot with jQuery and JavaScript, and it would move the images over by iterating through the left and top coordinates and sort of move things over. All the animation here is done using CSS. So as I scroll over, there's an event called. It says, hey, change that class to an animation event calls. And then now that all gets passed to the GPU, so it's nice and smooth, and it becomes a nice experience, there we go, for the end user. A better example of this is here. Now, what I've done here is I've put into a loop an animation event that is this. So all it's doing is it has some text, and it goes from font 300% to font 700%. Well, the problem is that fonts aren't accelerated. It's not one of those 4 things I just showed you. And so the CSS engine has to go through and iterate, go 301, 302, 302, 3, all the way up to 700, and then all the way back. So because of that, it's janky is the new hipness, right? So you can see, I hope you can see with the camera, it's a little choppy. It's actually very choppy on the device. So we're going to swap that out for this one. Can you guys see the difference? It's quite a bit difference, right? The difference is now I'm using scale. And I might as well show it to you since I have it. It's the same thing. Now I'm using Web Transform scale. So basically what happened is the renderer took the font, it was there, said, OK, great, here it is, and then passes it to the GPU, said, GPU, you handle it. GPU then says, OK, great, I know how to do that. And it did a matrix transform, and it just does it really cool. It used to be so much more impressive. I was talking about that when I was doing that. It does this really easily and very quickly. So this is the sort of thing you want to do. Again, this is back to performance, right? Use the tools to be as performant as possible. The GPUs on these devices are really amazing, and you get a much better performance for it. And all right, so the next couple slides kind of jump between CSS and JavaScript, so I'll use it as a transition. This is media query, so we're back to control again. We want to be able to say, hey, how is my user holding the screen? Chrome and Chromium-based browsers, such as the one on my HDX here and others, Opera, don't have a screen lock yet. So if the end user churns their page, it's going to churn. And so you have to be able to detect that and either adjust your page or at least show them something a little different than what they had before. This is the CSS way of doing it. There is the, you can see screen orientation, portrait, and landscape. And you can also do things like, say, I have a high resolution screen, so I want to present a certain picture or something like that for that. I've got more examples of this in a minute. And again, this is all about sort of control. Here's the same functionality, but now we're doing it within JavaScript. So if there was just some stuff you just needed to change, like say a background, you wanted to go from a portrait background to a landscape background, you would use a CSS. If you need to do some more complicated things, well, this is the way to do that there. Hopefully, in the future, Chromium will have a screen lock. We can then lock it up. We don't have to do this as much, but right now you have to kind of prepare, make sure you watch out for that. This is a great one. This goes back to our viewport. So let me pull over. We had our viewport before. We put it up there, and we said, okay, the device is device width, and we have a certain screen density. If you remember back when the iPhone was first launched, it had a 640 by something screen. It was a nice screen, but it wasn't huge. And so they put in the viewport so that we could take a larger screen, and it would be a virtual 960 pixel wide page. And so then it would take New York Times, which is meant for this, and it would shrink down to that. Well, now what's happening is the resolutions on our devices are actually huge, and our virtual 980 screen is too small. So what happens is, if you don't watch out for the viewport information, specifically pixel density, well, I have, again, a 1200 by 1920 screen here, and I've put in a beautiful picture of the Golden Gate Bridge. That's exactly 1920 by 1200. And I didn't do anything to the viewport, and this is what the background looks like. Well, I did some queries to the inner width and the inner height of the window, and this is what I got, 960 by 600. What's going on? Where's my beautiful screen that I have? Why can't I take advantage of it? Why is JavaScript lying to me? Again, it's because of the device resolution. So with the very header of your page in your JavaScript, you put this code in there. What it does is it's going to dynamically detect the pixel ratio and swap out the initial scale to reflect that. So on the HDX, the ratio is 2. So the device pixel ratio is 2. So the initial scale will be 0.5. This device here is a Firefox OS device, and it's got a 640 by 380, so it's just a 1. This is a new LG G2. This has a 3 because it has such a high resolution on such a small density. So because of that, if you dynamically alter the viewport, what you get instead is what you should get, which is a beautiful blurry picture of, let's see if we get that better. A little better. Oh, you can't really see you can't see anything, can you? Okay. There we go. So we get a much better view of this. I wish I could show you, but what's happening is a couple of different things. The device pixel ratio is coming up too, like it should, and the inner width and height are reflecting what it should be on the screen. Now, this is not without its penalties, because if you do this, all of your buttons, say I just put an HTML5 button in there, it's going to get tiny. All of the text will get tiny. Your UI will get tinier because the browser will be, by default, thinking you have your standard default pixel ratio and screen width. So it's all about control, but it's also about a balance. Like if I do this, I know that I now have control of my entire page. I can do everything I want to. I can have control of every little pixel. But now you're also responsible for every single pixel on the page. So it's something to definitely to watch out for. So I'm going to jump in now. Let's see, what are we doing for time? It's 10. Oh, okay, I'm going to quickly go through the rest of them. I can't believe how quick it went. Help me. Oh, there we go. Did I tap on that? All my demos went away. All right, let's do this. Go back here. Okay, so what I want to talk again is jump back to performance. And what we're going to do is go over some things you can do with the canvas. Oh, here we go. They came up. So here's a sample app I made. It's very simple. It is just you have to catch the colors, the balls that are coming towards the center. You have to catch them to make sure that they match up. And if they match, then it'll give you a nice little explosion. And you get points. And if you don't, then it'll make the middle grow until the nothing takes over. So this is your basic app. It's got some velocity added to it. Nothing overly special, but it's a neat little canvas app. It's a clone of one called Gyro that you can get on the App Store if you like. So the thing you want to do is you need to make sure you're intelligent about the canvas. Canvas is a very basic element in HTML5. You can draw to it. And then if you want to animate, you draw, you erase, then you draw again, and you erase. And that's how you do all of your animations and all of your sort of functionality. Now, I'm using sort of core libraries. And there's lots of game libraries out there. There's lots of different animation libraries and things like that you can use. And I encourage you to go explore them. But at the very core, you need to be sort of intelligent about what you're doing with the canvas. Because you can really affect performance just by doing some basic things. First is, if you notice in the very middle of that screen, I had this 4-colored circle, right? So the way I did that was I went from the circle of the radius out to the end of the radius, and then drew an arc over, came back to the middle, filled that with a color, then went over to the next color, and then drew the next wedge, and then the next wedge, and the next wedge. And then, as if I wanted to rotate, then I had to change my starting point and then do all those draws again. Now, that's not super complicated. Actually, it's pretty quick on these devices, but it's complicated enough that you don't want to have to do it every single time. And sometimes maybe you'll have Mario. Maybe you'll have a big sprite that'll be very complex and have lots of different moving parts. Well, you want to pre-render those out to a different sub-element, and then you can pull those into your main canvas page whenever you need them. Okay? This makes it a little simpler, and you can also use things like rotate, which is a function on canvas, and it saves you from having to write the code to kind of move all that stuff. The canvas is a state machine, and so you don't need to draw to it every single time you make a line. You can do all of your drawing, all of your lines, and at the very end say stroke. You see at the bottom. So it'll memorize all of that, and this way you can only have to tell the page to draw it once. You don't have to draw constantly, because every time you say stroke, you're going to make the renderer re-lay out the entire page, because you're saying to the canvas, I'm changed, and so it has to think about it and then do the processing. So you want to batch up your calls. And then also, other sort of game platforms, like actual consoles and things like that, will have dirty regions. You can say, hey, what has changed and what hasn't? Canvas is very simple, so it doesn't have those sorts of things. But that doesn't mean you can't keep track of it. And if you do, you can keep track of it and then say, hey, I want to just draw this differently. So if I moved my ball over just a pixel or two, I'm going to erase the old pixels, just that little square, and then move them over. Then I don't have to redraw the entire screen. My sample app is very simple, but it adds up. It becomes very quickly becomes an easier a thing that you want to keep track of, so that you don't have to constantly change the canvas to make it more performant. So. And again, this is the app again, and you can see that it's pretty good. And then just to show that here is the same app on using Chrome on my G2. And you can even pull it up. Is it focusing? Focus. There you go. And it can work pretty well on the Safari browser as well. So it's, you use your basic canvas, no libraries. I didn't have to worry about if the libraries are going to work on all these different devices because I used core HTML5, which I know is supported on all these devices, right? And the end result is pretty clear. Okay, let's see. All right, so I skipped over this part, but I'm also using request animation frame. In the beginning, I used it. The thing I want to show that's the easiest, I'll wander over this side because I keep using that one as an example. This way over here, if you see the grayed out lines just before the last, using request animation frame is trivial. Instead of using the set timeout like you would do normally inside of your function to call it again when a timeout comes, swap it out for this line of code. Now this, you may need a polyfill, and a polyfill, as you may know, is basically a bunch of JavaScript that sort of detects whether you need to have prefixed functions for each browser or whatever. So you can just grab a bit of polyfill, put that in your page, and then use it. Or if you know that it's going to be on a WebKit browser, then don't worry about it, just use this one. But I'm swapping out one line of code, and then suddenly now, instead of having the JavaScript to kind of guess whether its frames every 60 seconds is matching up with the redraw, now you know that every time the page is ready to redraw, it calls this function. So there's a lot of samples out there that kind of make it more complicated than it needs to be. This is how simple it is. The other thing that's very cool is that in the very top, you'll see that it passes time. Request animation frame always passes the delta of, not the delta, I'm sorry, the most recent time from when you started the calls. And so that allows you to do things like physics. So on my very low-powered Firefox OS phone, it may not be very powerful. And so if you want the physics to be done correctly, then the request animation frame may not be called as much as on a newer device with a higher powered GPU. And so you want to be able to keep track of time to make sure that balls bounce like they should do realistically. All right, so next few slides are about performance on the page itself. There are things that redraw the page. There's a huge list of them. Here's a good example. Anytime you change any of these things on any element in your page, your whole page has to be recalculated. Now that means it doesn't mean that things are changed very much, but it means that you're causing the browser to rethink, which is causing processing cycles. Anytime you do a query to even ask what something is in terms of its size or position on a page, you cause a recalculation of the page. So this is a big deal because sometimes in your scrolling, for example, or other events, you might call and say, where is this thing? Where is this thing? Where is this thing? I'm moving it across the page. Every time you do that, the browser has to recalculate. So what you want to do is debounce those things. You want to basically buffer them. And that way you can throttle down how many times you're calling, how many times you're querying the page, which will make the page more performant. Okay. So we're almost done. We're going to go through just a couple more slides about taking your app and making it offline. Or more importantly, you're going to package your application. There's a couple different types of mobile web apps. There's packaged mobile web apps where you can zip it up. And then there's hosted mobile web apps, which are sitting on a server, and they're served up just like a regular web page. But when they arrive, they're an application. So these are just a few things you want to look out for. On your server, you have to make sure you serve the correct MIME types for the package documentation, which is manifests and the app cache. There are 3 or 4 different types of manifests right now. Apple has, Chrome, like Chrome OS has their own. Firefox has their own. Amazon, we have our own. So there's lots of various ones out there. It's not particularly organized right now. Hopefully that'll get better. However, there is one thing that does work really well with it, which is app cache. So I'm going to give you a demo of what that looks like. But what happens is you can say in the header of your page, I want to use a cache. The browser will then, and then you list out all of the assets every single asset that your application uses. It's a very simple file. The browser will check this file, download everything, and store it. Sometimes it won't let go of it later on, which can be buggy, but it works really well when it does work. And so the idea is that every time your browser then gets that URL, the first thing it checks for, the very first thing, it goes back to the app cache, which is called name.appcache or something.app.manifest or whatever, some .manifest. Checks for that. If it doesn't see it, it assumes you're offline and grabs all the stuff from your local. If it does see it and doesn't see any changes, again, it grabs everything from your local. So this is actually cool for a couple things. Maybe most of your app is off, all the assets are really big, but they don't change much, and you have one or two things that change. Well, now suddenly the startup of your application is faster because it's pulling everything from the local, from your local storage. And the other thing is that it makes hosted web apps offline web apps. And I'll give you a quick example of that. So I've written an application before I joined Amazon, in fact, that is called, Flip. And it's a puzzle app. It's very simple. Let's see. Oops. So the idea is that, it's supposed to be in, there we go, much better. So let's see, 5 letters for play games for money. Anyone have an answer for that? So we can do this. And then it tells you, hey, you've won that bit. So it's a very simple app, right? It's hosted. It means it's always served from my servers. It's open source as well, so you want to go to GitHub and grab the code, you can do that. And so then I submitted it to the Amazon App Store, and it gets wrapped up as an app. So if you go to the apps, you'll see that it's there as a wrapped up app, which is very nice. It also, I submitted it to Firefox, the Firefox Marketplace. So the same app is on, this is the Firefox OS phone. This entire thing is being run by HTML5 too, which shows you the power of the spec. And again, this is my same app, and now it's running here on, I can just click random. Oops. And there it is on this. Oh, it's really washed out. Sorry about that, but you can see it's essentially the same app. Now the thing is, this device, I don't have a SIM in here. It doesn't have any Wi-Fi connection. It's totally offline, and it was offline because of the app cache. So the other thing you can do is you can do also packaged apps. W3C is working on a web app manifest. Hopefully everybody sort of coalesces around it. That way you can just zip everything up, put a manifest in there, and it becomes an actual app itself. So, and then here's our, if you want to do the same thing for Amazon web app platform, that's the way to do that. So, and then the last thing I want to show you is just some inspiration. I'm going to go back into my web app tester here. Now, you've seen my little WebGL app, and you've seen my little WebGL demo. But after in the HTML5 DevConf, after I gave my presentation, a developer came up and said, hey, can I try my WebGL app on your device? Because I didn't realize that the Kindle HDXs supported WebGL. I said, sure, this is great. And so he had never tested it before, never tried it. And this is what he loaded up and showed us. Yo, you want to see it, don't you? So it takes a little second to load. So this is a pure 100% WebGL application. I can look around here. I can fire. It's a very cool little demo. And just to show you that, we can go into here. Let's see. I don't know where to stop it. Let's try it there. No, that's in the init. That's not going to work. Down here. This would be better if I could know where to get to. Come on, something's got to stop this thing. Ah, there we go. There, all right. So you can see that I paused the app with the developer tools, it's a full-on WebGL engine run by JavaScript. I can then hit play, and it'll go back and start playing, get rid of my breakpoint, just like I would normally do. And there it goes back. So it's a full HTML5 application. You can download it, you can cache it, you can run it, and it's indistinguishable from native apps. Again, it's all about control, all about performance. And that's the end of my talk. I'm going to be at the, do you know where the games are? In the foyer there. I'm going to be there just soon after the talk, and I'll be there for a few hours. So if you'd like to come by and ask a question, see some of the demos, get more details. All right, thank you so much.